Well, hi, and thanks for joining me in my shop again while I continue with this really cool looking radio. And just going to recap where we are with it here. So, a nice simple schematic on this radio. So basically the radio is essentially working as far as I can tell, but does not seem to get a signal right at the very front end of the radio, which is out in this part here. So there's the first tube, 6A7, and there's the 6A7 sitting right there. Right there. So that's the first tube. This is the grid cap. So what goes into the grid on the first tube is a signal from the antenna. There's the wire going to the antenna, and you can see it's going to this set of coils. Looks like two sets of coils, two adjustments. So on the schematic, when we look at the very front end, okay, so here's the antenna, down through a capacitor, through its own coil, and down through another coil, and down to ground. And that's the entire antenna. It's actually not electrically connected to the radio directly. Instead, the signal from the antenna is, what's the right word? Induced. Induced by these coils into these coils. And then the signal carries on into the radio. So there could be a problem here with these coils, that they're not inducing a signal properly. Now why could that be? Well, any one of these coils could be open, and that could be a start. It could be an open wire in them. Secondly, there's a capacitor here. It's very small. That could be in trouble in some way. I don't think, like this shows an earth ground, or is that a chassis ground? I think that's supposed to be an earth ground. So in a sense, this antenna is completely electrically isolated from, from the piece of paper, from the radio. And that's not so common. So what this end of this thing is doing, I don't know. When I hook up to the antenna wire, here's the antenna wire right here. Am I just hooking up to the top of this? And so without a ground, this just isn't going to do anything. It's just not going to. It's not going to do much of anything. You know, there'll always be some connection between everything and Earth through some amount of capacitance, which would be extremely tiny for just a piece of wire far above the ground. But nevertheless, it's there. So even if you don't put this to ground, this whole thing is somehow interacting through capacitance with ground, and probably lots of other stuff around here too. So, and there's an inherent capacity just due to the mass of the wiring here, and very, very tiny, but still some amount of capacity. So you can still pump a bit of signal in and out of this antenna. But so that could be the problem. Just putting a ground on the antenna properly. Another problem are these two adjustable capacitors here. Here they are, right here. These two. They could be dirty, shorted out, something like that could be happening. We have some switches here. There's a switch here. There's a switch here. There's a couple switches here, and they're all the band switches, and they're basically shorting out. Like this one shorts out this coil, takes it out of the circuit. This one shorts out this coil capacitor, takes it out of the circuit. So on one band, probably the AM band, we operate, and I'm not sure if it's AM or shortwave, but on one band we operate one set of coils, and on the other band we operate them all together. That's how this radio seems to work. So one thing we can do is we can shove a signal, we can bypass all this, and shove a signal right into the 6A7. It's pretty easy because the grid cap's sitting on top. We shove that signal in, a regular radio signal, just like what would make it through the antenna here, a radio frequency signal, and see what comes out of the radio. And if the radio works well on that signal, then we know the problems are really in this area. But if I put a signal into this grid, easier said than done, by the way, if the result is the radio doesn't work, then we might be suspicious of this tube itself, the 6A7 tube. Maybe it's weak or something like that. So that's what we're going to do here. We're going to put that signal in to start off with. And to do that, I need my signal generator lead here. Because if you remember, we were feeding the signal into the antenna from the signal generator, regular RF radio signal, And the radio was picking it up, but something terrible. It was picking it up just horribly weak. And clearly there's other stuff going on with this radio. When you tune it up towards the mid-range, something funny happens. I mean, there's other stuff going on with this radio. And I suspect this isn't going to solve all the problems with it. So don't misunderstand me. It's just another step along the way. So let's see. We're all plugged in. Just move this so you can see the red safety light in case it comes on. And I think we're just about ready to give it a go here. There we go. Switch is on. We're on the low power setting. You can see the light coming on over here. It looks much brighter in the camera than it actually is. It's very dull from my eyes. And remember, it's a very slow warm-up for a radio on restricted power. We're probably running a gain around 90 volts here. Turn it up a bit. I'll wave my magic screwdriver over it. Remember too, there was a lot of crackling with this radio too, which is another element we have to hunt down. So, well, you know, that just gives you an idea right there. Just using my finger, and if you jam a good signal into the front into this tube, you can hear it. But let's carry on with the signal generator. By the way, I put my finger on top of that cap only because I know there's no voltage there, because I tested it yesterday in a previous video. So there is always the possibility that the high voltage blocking cap, maybe not for this tube, but for other tubes with grid caps, the high voltage blocking cap is shorted and there's actually a high voltage sitting on that tube, which is a bad thing for many reasons. But another one is, you know, just put your finger on top and find out that way. That would not be much fun. Okay, so we think we're on the shortwave band up around 18. Up around 18. How come we don't hear the IF blasting away in there? I thought we had the IF just leaked into this thing like crazy. Oh, that's kind of odd. Okay, let's go up to the 18, not to get too distracted here. 18, eh? Nothing whatsoever. Okay. So, good question would be, what am I doing wrong here? Oh, here's the answer. The end of my lead fell out of the plug here. So, let's turn it down. Turn it down. Plug it in. Okay, now we're feeding a signal into it. Apparently feeding lots of stuff into it. Let's see. I'm not absolutely sure of the band switch position. Yeah, there's nothing going on here at all. I don't get it. Okay, let's repeat what we did yesterday. I'll just hook this up to the antenna wire here. I was sure we were picking this up. Wait a sec. I think I'm on the shortwave scale. We should hear it this time. Especially now that my furnace is shut off. There it is. Where'd it go? I heard it. Nothing. I was sure I heard it there. Oh. Be careful now what I'm touching at the same time. You know, I'm going to double check the voltage on that chassis before I get myself in between two things I don't want to be in between here. Should be a 0. Yeah. Just double checking because I'm handling various grounded items while I'm touching the knobs here. Okay, so we're not getting anything. How come? What happened here? There it is. Okay, so based on the fact that we saw this ground point, I'm going to try to imitate that with my signal generator. And we're going to ground the signal generator to the chassis first off. See what that does. Doesn't do much of anything. That's grounding it to house ground. That's how it's done now. It didn't make any difference. Well, I get the impression these coils are not working at all. But why can't I feed the signal straight into that grid? Why would that be? Let's put a teeny tiny capacitor in there. So I'm off the antenna now. This is my signal generator lead. Turn it down here so I don't blow us all away. Okay. Let's try that out. Huh. Sounds more like a radio, doesn't it? That's the signal generator for sure. Off ground, on ground. Makes some kind of difference, huh? Here's the ground connection, by the way. It's just one of my outlet bars. I gotta remember, I got the speaker pretty much aimed right at the microphone here, so don't want it to be too loud. Well, you know, this is sort of suggesting the 6A7 may be not so good, or there is something that is really suppressing the signal on the way into that tube. All kinds of capacitors in here. Oh my gosh, look at them all. Boom, 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 boom. Whew. But this is our problem area. I think we should check the continuity of these coils first. And after doing that, we can poke around, look at some of these capacitors. Some of them are very variable adjusters, like this kind. Others are fixed. And there's some more adjustable ones here. I don't know where those are. And somewhere in here is the actual tuning capacitor. And I can't spot which one of these is it right now. It's a two-part capacitor, so of course one part for the oscillator and one part for tuning the antenna system. Anyway, I'll sort that out, and let's check the continuity in these coils first. So we're gonna power it off. Not that it really needs to be, but okay. So I just have to hear this. Oh yeah, now, I think all I gotta do, what have I gotta do? Okay, these two variable capacitors are right across this coil. So I just put my leads across here, and I should hear the short through the coil. The switch here can cause the short. I'll have to operate the band switch one way or another and see if the short goes away. Hopefully it doesn't. So we just go right across this capacitor, these capacitors here, and we should hear a short. There's one. There's the other. Operate the band switch and repeat that. Okay, so that shows that these front coils, these two are good. Now what about these two, the antenna itself? Okay, so I take the antenna wire. Where'd it go? Here's the end of the antenna wire. And what I'll do is I'll clip that to one of the ohm meter leads. Okay, so we should be able to find, oh look, the antenna comes right in through a capacitor. So I shouldn't get any readings anywhere doing this. Nowhere. Yeah, there's the capacitor, I think, right there. Right behind there. That's a pretty good view of it there. man, it's fantastic what I can see with this camera compared to my eyeballs. So, wow, it's really great. So you can definitely see the capacitor sitting there. Back here. Oop. And lots of little dusty dirt here. Look how they've supported it. It's on this wooden dowel. And they've used a wooden dowel back in here too, as a standoff. Now how can I sort out what is what on this? So that capacitor, we can make the assumption that that capacitor is this capacitor on the antenna. It's a bit of an assumption because here's another capacitor on this coil. So it could be this one, or it could be this one. The size would be the giveaway. This is a tiny one, 0.006. This one's a 0.01. It's kind of a medium size. That's a fairly large capacitor in there. Can we possibly read it? Well, let's go looking with the camera because I'm not seeing anything with my eyes. That looks like 006 right there, and that's what it's supposed to be. So that is the antenna capacitor, 006. Now, what could have happened to it is it could have no capacity anymore, but that's not very likely. It's really not very likely. It's possible it's just open. Literally the lead at one end of this capacitor has separated inside the capacitor from the rest of the foils. And that would give you almost a zero capacity there. 0.06 is not much to begin with. But if it hasn't opened up like that, a short circuit here wouldn't stop this. I don't think it would stop it from operating. I don't know that that capacitor is part of the resonant circuit of the antenna, but I guess it kind of has to be, doesn't it? Reacting against the coils that it's connected to. Well, let's put an ohmmeter across it. I mean, why not? We'll see what it does here. Okay, here we come. One side. Wow, the camera's fantastic. Unfortunately, I can't see 3D in the camera though. There we go. And of course, it's showing an open circuit, just what we would expect. Now, considering I've pumped the signal, well, you know what that does now? That marks some of these coils on that form. So now we know where this point is, right here. Oops. That would be this point. Right here. We know which coil this is. So we can check the continuity of this coil now. I wonder where this ground wire point is. Because often there's two wires hanging out of radios like this, a ground and an antenna. And the antenna, we're assuming this is the antenna. Maybe this is the ground side of it. You know, maybe somebody made a mistake here. Maybe the antenna side's missing entirely. We'll have to investigate this for sure. But we'll check this coil and this coil. Boy, it'd be great if I could find this. I just right across. But I can't, so we'll try right across the coil here. You know, I'm not sure which of these connectors are the right ones to hit, but well, I know this one is. Well, there's a short there. So there's some continuity. Now that was either in effect that was either It's either me touching this point, or I'm down here somewhere. It could be here, or it could be here. So I tested this coil. I think we can be quite certain this coil is good, based on what I just did. Now what about this one? The only hint on that other coil is that there should be a wire heading out to, quote, ground, whatever the heck that is. Let's tip it up and take a look underneath and see if we can sort out what's going on here. Okay, good enough. So let's trace this wire back. Let's see where it's going. What a mass of parts, eh? Holy smokes. Okay, so there it is wiggling down there. There it is wiggling there. And it certainly looks like it's headed for a hole that it comes up through. A little too much dust in there. Let me de-dust it here. Let's do a quick de-dusting job. I can tell my wife now the vacuuming's done for the day. I did it. Okay. Okay, I can see movement up above here. I can see exactly where it's connected. It's connected to a terminal that goes to one side of that capacitor. So it's connected to a terminal that goes to one side of this capacitor. So the terminal is probably doing nothing but just a good place to connect wires. Probably doesn't connect up into any of these coils. Yeah, I can see it down there. How flexible is your camera? I'm not quite sure what I'm showing you there. Let's wiggle this wire, see it. Okay, now if we can get a focus to come. See it moving? Wait. Now, there. See it moving there? Yeah, you know what? It moves almost like it's not soldered properly. Let me just get the camera right. Ah! Everything's upside down and backwards here for me. There we go. Nope. That moves a little funny there, doesn't it? Let me get a grip on it. It's either actually not soldered properly, broken, or hanging by a thread. Something like that's going on here. Okay. It's a tough spot, so I could see a wire going in here and not getting soldered, but fat chance, really. Okay, come on, focus now. Yeah, I think the funny motion is the motion of the whole coil there. Well, I can't imagine there's a problem there. But we know where to feed a signal in past that capacitor now. And I've essentially done that by feeding it right to the top of the tube there. I guess I could put the 6A7 through my tube tester and see what it tells us. That might be something worth doing at this point. No, that doesn't make sense, really. It really doesn't. Because I can put my finger on the grid cap and away she goes. Let's only check the oscillator on this radio, because when you tune it, you can hear a pitch going up and down. That's kind of weird. And it could be the receiver's receiving nothing because there's no oscillator oscillating. Yeah, why don't we do that? So we'll use the scope to do that, I think. Give me a second here and I'll set up.